Um, we're going to be spending most of the afternoon with a number of hands-on examples and going through an example model, but I wanted to generalize a little bit from what we've seen about the use of events in AnyLogic, because they're a very powerful mechanism that can be underappreciated. And they actually afford significant flexibility if you know how to take advantage of them. So within this context, I wanted to speak about how events are used in AnyLogic and reflect a little bit on different types of events, explicit events that are made available. AnyLogic is an event-driven system, and what that means is that that events are at the core of kind of how it simulates a model. At a very material level, AnyLogic, it maintains a scheduler that jumps from event to event to event. If there's more events to be handled for a period of time, it will do so. And then it may jump forward to events that are further off in time. So in contrast to sort of the step-by-step character, the regular ticks you see in a lot of discrete event, a lot of agent-based modeling packages, or the standard fixed time steps you see in system dynamics. Here we have an event-driven architecture, and there's something called a scheduler that's going on beneath the surface, which actually handles the various events. Sometimes queuing up events when needed, like when someone sends a message, it queues up an event to be handled, and then dequeuing events when certain events are preempted. For example, if someone dies or receives a better example, if they receive a message and they get infected, and that preempts them, for example, leaving on a transition to go to school, that going to school will be descheduled. So certain events can preempt other events and can essentially rule them out. Someone leaving via a message transition may not go out another transition that had originally been scheduled. So events are a central component, central factor shaping performance in the model. And we've seen a number of types of events within the model. We've seen transitions, for example. We've seen, and on one or two occasions when we start a model, we've seen that there's events associated with that. So if we load in one of these models that we were just running, if you go to main, you'll see that within main, as within other agents, there's agent action specified here on startup, on destroy. So this is when the model is just being started, or when it's about to cease operation, and then on arrival to a target location, when this agent arrives to a different location. And these are, in some sense, implicit events, in the sense that they're not reified as event objects. They're things that are handlers you write. So when something happens, when a transition fires, when you enter a state, when the model starts up, when it finishes, things that code is executed. Okay, and we've seen a fair bit of that sort of example. For example, when the model started, we sent a message from main to a randomly chosen agent within it. Right. So in addition to that, we've seen that you can add explicit events to the model. And the one we focused on is this event shown here with sort of a lightning bolt. And that's the primary event construct you'll be using in these models. But it's not the only one. AnyLogic also provides this dynamic event. Static events can only have one scheduled firing sort of schedule for them. We've seen that static events can be added to a model, and you can specify their modes of operation. For example, how frequently should they go off? Should they go off in a regular way or an irregular way? And those events can be used at the person or agent level. So, for example, this birth arrivals event here, right? is arriving at a rate 10, but we could have scheduled it as a timeout, and we could say whether it occurs just once or multiple times with a fixed separation, or whether it occurs on a transition. These are very, very useful constructs, as I said, and are very valuable when building up models. But there's a limitation to them. There's one schedule. You have an event that goes off at certain times, and maybe it's according to a rate, or maybe it's according to a fixed time between things. But there's only one schedule involved. By contrast, the dynamic event can have many copies of itself, and each of them can be scheduled at different times. And they can be scheduled basically forward at arbitrary times. They can go off once at a time of your choosing. We're going to talk about them a bit. A little bit more about explicit events. These explicit events, of these ones that we've seen thus far, they have a lot of flexibility with them we haven't tapped into. You can actually explicitly call restart an event to sort of schedule. So I recall a new instance, sort of to get it to recompute when it will go off next. An on-change event can be called to get it to recompute the rates for it, and you can get it to reset it. By resetting it, you can disable it. Okay, so you could disable it and then restart it in order to get it going again. So you could sort of pause an event if you want to pause the birth arrivals for a certain amount of time. By pressing a key or by something else going on in the model. You can do it with this reset by calling reset. Okay. Okay, we've talked about these a little bit. I'd like to talk now about, so any questions about events as a general, the sort of events we've seen before I go into dynamic events? Any questions about these sort of events? Restart or reset? Okay, so if I wanted to do that, for example, birth arrivals, maybe when a baby has arrived, maybe I want to, for some reason, pause subsequent occurrences of that event. So I could do birth arrivals here, and then I could actually call, so this is when it goes off. I could actually call, to reset the event, and this will actually stop it from primary, it cancels it, okay? And so I can actually stop it from occurring. Or I could have a button. Here's another example. I could have a button. This is the last model we built, this model with the population sort of coming in like this, and babies are born, and other people age. Suppose I wanted to take this model, and I wanted to do it so I can disable births. Okay, so I could drag in a button here. Okay, there it just took a bit of time to arrive. I have a button, and this will be disable births button, something like that. And I'll call it and give it a nice label, disable births. And I might, from that, tell it, when I press it, I'll tell it birth arrivals dot reset. Okay? Reset. Okay? And that's the action. When I push this, this will happen. That's an event of sorts. It's sort of, this will fire off. So watch this. So I do this, and births are occurring. People are coming in here over time, and I could say disable births, and now no new births are occurring. You see that? See that? And I could create another button if I wanted to along the same lines, which would be re-enable births. So this might be re-enable births button, and I'll give it a nice label of re-enable births. This is just a little label for it. And here I could do birth arrivals dot reset restart. And this will basically re-enable it. So suppose for experimentation purposes, and this is very useful as a modeler, when you're experimenting with your model to be able to sort of disable certain things, re-enable them. So here births are occurring. I want to disable it. No new births are occurring. Now I'm going to re-enable it, and now births are occurring again. You see that? Yeah. So that's an example of sort of enabling and disabling events. Okay. Okay. So fairly flexible, actually, once you take those things into account. Any other questions on those sort of events? Yes.
Are you able to create your own types of events by presenting events class?
It's a good question. I've used dynamic events for that sort of purpose. In a way, they're kind of like that. And you don't have to explicitly subclass the event class. It'd be an interesting idea. I've never actually done it, and I imagine it would work. It could work probably decently well. I don't see a problem with that. AnyLogic has a Java type hierarchy, and you could subclass it and declare your own features. You just want to be careful of certain basic principles, like the so-called Liskov substitution principle, so it's compatible with how they've implemented it. But yeah, I think it'll be quite possible. I'd be very shocked if you can't do it. But I haven't felt a need in all these years of modeling to do it, and partly it's because of a dynamic events, okay? So I'd like to talk about dynamic events. What do they bring to the table? Okay, so a dynamic event is like a static event in the sense that it's an explicit object that's associated with an action to invoke when it occurs. So with regular events, there's not a lot of purposes of having these things firing off without an action to be undertaken when they happen. It's kind of their job in life is to kind of do something at certain times, right? In this case, it's a regular, according to a rate. Other times it might be a timeout in a cyclic way to report to a database how many people are alive, or to print it out in a file or what have you. Dynamic events, though, a static event is a single associated schedule. It may fire off many times, but it's with a single schedule. But a dynamic event can have many, many copies of itself with sort of multiple instances of this, okay? And each instance can be scheduled at different times. And the scheduling for each proceed in parallel. So you could schedule many given particular cases of this event to be going off. It's its own sort of one-shot event, okay? And as such, it's different. We schedule it at a time, and we basically say, we want this dynamic event of this certain sort, which has a certain handler, to go off 3 months from now, 6 months from now, a year from now. And when it goes off, the notable things will happen, and I'm going to pass it some information, okay? So the idea here is, and I'll jump forward to some examples. We've used them in a number of cases. I'll just mention 3 examples, which I think are interesting little cases. One thing is, so we have a very detailed model of deer interactions and movement in our fair province of Saskatchewan. These are mule deer. They move around a landscape, and just to liven this up a little bit, maybe I'll load this model in. Gives you a bit of a flavor, and we'll see more about it later. So in this case, we'll say we're going to be interested in capturing specifically some movement associated with deer mating, so mating of deer, and we actually simulate the mating of deer. Now, when deers mate, that gives rise very often to a fawn, but that fawn is not born immediately. That fawn occurs at a later time. So this is a model of mule deer within our province, and you see these deer moving around. Here's water sources, and they're associated with various physiological properties that lead them to need water at certain times, to need food at other times, and they move around. You can set them to move in herds. This is a very early version of it. It's gotten a lot more sophisticated in terms of its representation of deer movement. And over time, they shed prions, which are these misfolded proteins. And moving over the landscape, they'll sometimes encounter each other. They move in herds, and during rut, during this mating season, they actually mate, and a new deer is conceived. Now, that deer has got to be born. And so two deer come together, and we might at that time save up information about the parent deer to determine something about the status of the deer that's to be born. For example, the genotypes of the deer, the infection status, the stress level of the parents, or what have you, location where conception occurred. And we work with deer researchers for whom there's a number of types of information that are of interest. But the point is, we have to sort of schedule at the time of mating this future deer, this birth of a fawn from now. And as a result, we need to remember sort of these characteristics for that time. So for that, we can create a dynamic event. A dynamic event will actually allow us to sort of store up the requisite information. We can say, schedule this event, 9 months from now, with these information you'll use at that time to make it happen. So we bundle up this information that will be needed 9 months down the road about the deer to be born, what its genotype will be, information about its history, etc., its infection status. But that baby won't be born yet. It'll just be this event we scheduled, so with the passage of time and with the melting of winter snows, that deer will be born. Boom. 9 months from now. Critically, we pack up all the information we need to specify at the time of scheduling this so that it will be born later. And so, for example, we might have a scheduled deer birth event here, and we want to specify that we want to specify the sex that will be, the genotype associated with it, the latitude and longitude associated with the mating that occurred behind it. And we could bundle all that information up and basically say, go schedule this thing. And it will schedule a deer birth 9 months from now, which when it happens will create a new baby, which has these characteristics, a new fawn. And that will be the evening of the fawn. Okay? A second attractive use of dynamic events is, suppose you want to add people into a population over a time interval. We have a very large-scale model associated with diabetes and end-stage renal disease in the province that you folks will probably see. It's one of the models I provide to you. Its name is the Beifong-Ren model, and this model simulates the historical data where possible, and then shifts to prospective data generated purely by the model. So while certain historic data is available about people developing diabetes, it uses that information. But the problem is while we have something like 97,000 individual records of diabetes cases in our province, it's a province-wide data set from our Ministry of Health, we don't actually have information on the day that people got diabetes. And here we are simulating this model on a day-by-day basis of the evolution of the population. So these people will come in 1986, they'll come into the model and as new diabetics, and we need to schedule them so they come in all the way through the year, rather than coming in all at the beginning time of the year, the very first day of the year. So here we sort of find out as of January 1st how many have to be scheduled in the course of that year, and then we schedule using dynamic events for each of them, say, create a person with these characteristics 6 months from now, or 3 months from now, or 2 weeks from now, or 200 days from now. We sort of schedule them to occur through the year. We have information on how many of them need to come in from a system dynamics model, and we can pre-schedule them so that they are sort of spread out through the year. We don't know the actual date of diagnosis, so we sort of spread them out through the year in a uniform sort of way. So here we schedule a dynamic event And January 1st, we scheduled dynamic events for all these people to create them with the requisite characteristics at the appropriate time of the year over the course of the next year. Okay. So here we are using this dynamic event to schedule people who we know should come in sometime during this year at the requisite time. Another example that we saw recently was a case where we have people presenting at a clinic, and then they leave the clinic and go back home. And when they leave the clinic, based on their condition and certain situations, they have a certain chance of having a new appointment scheduled for them. A new appointment is maybe scheduled for them to return in 3 months' time or in 6 months' time. So there's a certain chance a new appointment will be scheduled. And here, we want, when a new appointment is reached, a message to be sent to the agent, say, hey, come back to the clinic. You have your dental appointment due, or what have you. So to do that, we can use a dynamic event. We check, okay, if the person is of these characteristics, we'll schedule an appointment for them. And basically, we create a dynamic event that will specify at this certain time, send a certain person a message that will say, come into clinic. 3 months from now, that event will go off, that person will be sent a message, and they may or may not come in as a result, but it will trigger a transition in their state chart that might lead them to presenting. So this is a third use of dynamic events, which we've seen in our work. Any questions about dynamic events? They're not very widely used, but they're very powerful. And sometimes they hit just the mark you need. We haven't seen a huge amount of use for them, but when they've been needed, they spared us a lot of worry about how to implement something. So any questions about that? The beauty of it is you wrap them up with the information they need when you create them. When you schedule them, you provide all this sort of information that will be needed so that when they get fired off, they can do their job. In a way, it's a little bit like that function. You give the function all the information it needs, and it does its job. But here, you give them all the information they need, and they wait until the requisite time, and then go off and do their job. Any questions? Questions about this? Okay. Little subtlety associated with AnyLogic support, very, very powerful.